believe it or not, a recent survey of over 8,000 people showed that only 84% of respondents believe the Earth is round, while the other 16% express various degrees of skepticism, which is crazy. Not only have we known for centuries that the Earth is round, but someone born almost 300 years before Christ was able to measure the circumference of the globe with remarkable accuracy, using only a stick and the sun. Eratosthenes was a Greek scholar born in Cyrene, the oldest city in the Ptolemaic kingdom. He studied in Athens and was so accomplished that the pharaoh appointed him as the chief librarian at the famed Library of Alexandria. His most famous experiment was completed here, but actually began 500 miles south in the city of Syene.
One midsummer's day, Eratosthenes noticed that no vertical shadows were cast at noon, meaning that the sun was directly overhead Syene. He concluded that this must be from the sun's rays hitting the Earth's surface in parallel lines. This got him thinking. The next midsummer's day in Alexandria, 500 miles north, he put a stick in the ground at high noon, and as he expected, there was a shadow. He measured the angle and found it was 7.2 degrees. From this point on, it was just simple math. Since the sun's rays are coming in at the same angle at the same time of day, and one stick is casting a shadow while the other is not, it must mean that the Earth is a globe. Moreover, he knew that 7.2 degrees wasn't just the angle of a shadow, it was the distance between those two cities on a 360-degree globe. 7.2 degrees is 1/50th of a circle. So knowing the cities were 500 miles apart, he concluded that the radius would be 50 times 500 miles for a measurement of 25,000. He was only off by 99 miles. So the next time you hear someone talk about the flat Earth, just remember that someone born almost 2,500 years ago was way ahead of the curve.
Here's a map of ancient Egypt. I've inserted 2 sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment.
For a theory to be scientific, you don't have to be able to observe everything it predicts. You just have to be able to observe at least one thing that it predicts.